Hi, I'm Pundit for Fun, and in this video we will compare the Einstar Rockit in the scanning modes Markerless laser scanning and near-infrared scanning on a frog statue. It is made from it's concrete basically. You have the eye section is polished metal as well as the arms. For the scanning process itself, I covered the metal section with some skin spray since they were quite reflective. Also, like the copper paint didn't help. Looking at the scan setup, I just place the statue on a turntable so I can rotate it. But I found out since the scanning range in the near-infrared mode and also in the Markerless laser mode, at least for the tracking, is so large. I got better results when not turning the turntable, since it also tracked the table, tracked the texture of the table, tracked the flask I had nearby, so it messed up the scan when I started rotating the frog. Of course, this could be mitigated when reducing the tracking distance, or generally the working distance of the scanner. But I didn't do this because I wanted best tracking, especially for the head part, where it is quite a small and regularly shaped part. So I didn't want to reduce my chances for a great scan turnout. Now we will first start with the with the infrared scan. The infrared scan. I chose the medium to large preset with a 0.5 millimeter point distance, or target point distance, I have to call it, with hybrid tracking of features and texture. You have to keep in mind you can also use markers, but when using markers, the total working distance gets reduced to, I think it is 60 centimeters, since it has to reliably track the markers which are quite small, and I guess the camera resolution is a limit, so it is limited. Starting the near scan, you can see I'm simply going around the frog, starting from front, going around the back. I sped up the footage by the factor of 2, so it won't be that long to look at it. But I guess you get a glimpse of what is happening. Looking at the footage, you can also see it is capturing the chair, it is capturing parts of the floor, most parts of the table, so the scanning range with the Einstar Rockit is quite large. You can see I paused the scan at this point to look at the current state of the scan, since I wasn't sure how well it captured the arms, since they're very thin metal tubing, but it captured them actually quite good. As a sort of a spoiler, it actually captured them better than in the Markerless laser mode. Okay, I sped the footage of the post-processing, or the point cloud generation, up by the factor 16, so you don't have to endure it as long as I did. I hope the software will improve for this step. Currently, it bugs me a bit off that you have to do the point cloud generation when you finish the scan. You cannot just stop the scan, start directly a new scan, and continue point cloud generation. Okay, here I'm removing the parts of the scan that I don't need, and I'm generating. No, at this point I'm just finishing the removal process. Okay, here you can see the point cloud preview. That's not yet the mesh. I'm creating mesh in the next step. I just use the default meshing settings. Most often I'm quite fine with them. You can see there's still a software bug in the version 1.043 where it sometimes reintroduces the deleted data. But I think in the most current version it is already fixed. Okay, now I just do some texture remapping and adjust the textures within the software. You can see the frog is looking quite nice, and I'm simply exporting it as an OBJ file to later compare them. In the next step, we will now look at now perform the Markerless laser mode. It is also taking place in 0.5 millimeters target resolution. You also always have to keep in mind it's a target resolution, it's not the actual scan resolution. The Markerless laser scanning speed is limited to 20 FPS. You have to keep this in mind. So in marker mode it can do 90 FPS, Markerless it's 20 FPS. I guess the reason is it is connected to the near-infrared scanning. So it basically uses the lasers for the gathering of the actual points, but it uses the infrared emitters and also the cameras to track it. So like it uses both scanning modes at once. I was quite surprised that the Einstar Rockit doesn't require as much performance in the PC as I thought. I have a workstation with a RTX 5070 Ti, modern Ryzen CPU and 64 GB of RAM. Of course, it works flawlessly in the max frame rate. What was more surprising, I have also a notebook. It's like a thin and light Lenovo notebook. It has a RTX 3050, so it's an okay notebook, I would say. But it's a thin and light notebook with a i7 of the 12th or 13th generation and 16 GB of RAM. So 16. Way too little normally. But at least the scanning part was also working quite nice in the notebook. Like I hit the 90 FPS in marker mode, I hit the 20 FPS in the feature-aligned laser scanning mode. But I got problems when trying to finish the scan, because finishing the scan also means generating the point cloud, and this step it consumes the most RAM. For the frog, I opened Task Manager while it was generating point clouds, and I had up to 45 GB of RAM usage. Maybe I overdid the scanning. This could be possible, of course, especially in near-infrared mode, but I wanted to be sure to get all the data needed and the quality needed to make get a good explanation or good example of the scanning quality. Now we have the point cloud generation step with the laser scan mode. And it takes, of course, a few seconds, but here we see the point cloud. In the next step, I will create the actual mesh file in the laser mode. So this won't take very long. The mesh file was like twice as big as in the near-infrared mode. So near-infrared was roughly 2 million points, and in the laser scan mode, roughly 4 million points. All right, so let's have a look at the two scan results and compare them. The software you're currently seeing is Meshlab. For me, it is also some kind of novum. I haven't used it before. I mostly used Quicksurface, but I found it to be quite suitable for comparing scans, since I can create a linked split screen. Okay, on the left we have the frog scanned in Markerless laser mode with the Einstar Rockit, and on the right we have the frog scanned with the near-infrared mode on the Einstar Rockit. And from our first view, maybe the main difference you will see, the infrared mode actually captured more of the arms, but the eye section is way worse in the infrared mode. So maybe let's dig a bit deeper into the scan. So if you look at the eyes, I guess it is quite apparent that the laser mode captured them way more clearly, whereas in the infrared mode they look like a bit phased out, I would say. This result can also be seen from the back. So the laser mode managed to capture this thin sheet metal quite good, whereas in the infrared mode it struggled. I must say that the eyes are made from sheet metal in a shiny color coating or spray paint coating, but I applied scan spray on both cases. The same is true for the arms. So also these were scan spray coated. So I'm a bit of surprised it didn't capture more in the markerless laser mode. But I mean, some kind of general theme is in the markerless laser mode, the scan results look a bit sharper and a bit more like realistic to the concrete casting of the part itself. Also, when going here down to the hands of the frog, I would say, you can see that these metal plates in the laser mode are way more defined than in the infrared mode. And also in the markerless laser mode, the surface quality is a bit smoother. I didn't apply smoothing in the post-processing, but in the NIR mode, I think there's generally a bit more noise. This may be due to the fact that here in the lower section, maybe the scan data quality was worse. I scanned until full quality, until full quality was reached. But I guess there's still differences in the capturing. But you can see the NIR mode even achieved to capture the turntable I placed the frog on. So this was the first section of the comparison. Okay, so now we are in Quicksurface. It's basically the same setup with the comparison of the two scans. This is just for like your opinion, what you think is a better presentation of the scan comparison. Because here in Quicksurface, I guess they are linked together. Like on the left you have the laser scan, and the right you have the NIR scan. Just leave a comment or give your opinion. What is like more clearly to understand when looking at the scan results. All right, I last minute decided to add a small addendum to the comparison by also including the Sermoon S1 scanner in the NIR mode. I will choose the infrared mode, normal object, large size since the frog is roughly 75 centimeters tall, geometry tracking, and standard field of view. For the Sermoon S1, you have to decide between you have the standard field of view using the standard cameras also used for the blue water laser scanning, and you have the wide angle cameras. These are used for the really big scans, like when I scan my whole couch or whole car interior in one go. But you of course get a gross resolution. So that's like the trade-off. So let's start the preview. I will just set the settings to auto. They are already in the mode, so now I can start a scan. I'm using the Sermoon S1 in wireless mode, so it's working quite fine. It's even hitting the whole 30 FPS wireless, so that's quite nice with Sermoon S1, that the wireless NIR speed is quite fast. Keep in mind, in laser mode wireless, it only can reach 40 FPS, whereas wired it can reach the full 90 FPS. So that's like a bit of a limitation, but the Sermoon S1 is also a bit faster in data gathering while laser scanning, so this remedies this issue to some point. So it looks like we hit the scan data quality it demands. So we will pause, finish the scan, and directly perform the fusion step. In the other scans with the Rockit, we chose 0.5 millimeters resolution. So I will also do it in the Sermoon S1. I'm not so sure how it will behave with this resolution in the large mode, since mainly the large mode is, I guess, more suited for 1 millimeter resolution, I would say. So with the Einstar Rockit, we could also choose like the preset target resolution for the near infrared mode. Whereas for the Sermoon S1, in the near infrared mode, you cannot choose the target resolution. So that's like limited to the laser scan. Okay, now let's wait a few seconds. Alright, so with the Sermoon S1, there's some sort of specialty in the new software version, the fusion step already generates a mesh file. So you don't actually need to perform the mesh generation step. So here we see the results or the comparison between on the left, the Einstar Rockit in the near-infrared mode, and on the right, the Creality Sermoon S1 in the near-infrared mode. I think they display different kinds of post-processing mostly. Like you see the Einstar scan on the, sorry, I need to link the windows. The Einstar scan is a bit rougher around the edges at some point, but it also provides more detail on the surface. Like if you look here at the different propulsions on the concrete, here at the bottom, it looks a bit edgier, if I can say it like this. Whereas on the Sermoon S1, it looks a bit more smoothed, but therefore also optically more pleasant. So this is like the one I would like to print out, and this is maybe the one I would directly take, or maybe would even manually smooth in the post-processing. This will be more highlighted if we use a shader, like radiance scaling. Radiance scaling highlights the surface defects. So here, especially on the head, we can see the differences quite clearly. Also here in the front of the body, on the legs or the frog's toes. But keep in mind, this is just a very rough, very quick comparison. On the back, it is even more prominent that the Sermoon S1 is maybe automatically applying some sort of smoothing. You have to find your own opinion, what you think about this kind of approach for post-processing.